All right, this recording is going back through the notes that we went through in class in case you need them. I'm just going to talk through it, and you should pause and re-listen to portions as you need if I go too quickly. So it's going to be a pretty short video, and then you just need to re-listen to things if I go too fast. Okay? So a circle is an infinite set of points equal distant from the center. That's why I created a whole bunch of dots around the outside to show that a solid line is created by an infinite number of points, all these points being the same distance from that center C. Okay? The radius is halfway across the circle with endpoints at the center and one endpoint on the circumference of your circle. So you can have an infinite number of radius, all the same length. It's the segment that connects the center to the exterior of your circle. Okay? A chord is a segment with endpoints on the circle. So you'll notice that this chord has endpoints on the circle, just like a diameter. A diameter is a chord, but the difference is a diameter has to go through the center of the circle. A chord doesn't necessarily have to go through the center. So we made these little notes over here. Not every chord is a diameter, but every diameter is a chord. It meets the definition of a chord. Okay. We had a student say it's kind of like the idea that every single square is a rectangle, but not every rectangle is a square. That same idea between chord and diameter. All right, a secant is a line that intersects the circle in two spots. So you could have many different secant lines cutting through a circle. So AB is a secant line. I could have another line cutting through here. C, label this one C, label this one D. And that's also a secant line because it intersects the circle in two spots. Okay. Tangent is a line that intersects the circle in exactly one point. So that's point A right there. The tangent line is this blue line M. Okay, I just put A as the point of tangency, which connects to if you connect the radius to the tangent line, it always forms a 90-degree angle. So just some things that we talked about during class. Okay, point of tangency is A. It's where the tangent line intersects the circle. I wanted you to star central angle, inscribed angle, minor arc, and major arc because those ones will come up a lot. All right, we have a central angle, V, which has a vertex at the center of the circle. So any central angle has a vertex at the center of the circle, and its sides of the angle are the radius, okay, are two different radius. So this angle here is a central angle. An inscribed angle has its vertex on the exterior of the circle, on the circumference of the circle, okay? And so, and it has sides of the angle that are chords. And so you'll notice that an inscribed angle here has a vertex on the exterior of the circle. Okay, and an arc refers to a portion of the circumference of a circle. Okay, and we use the notation with a little arc above the endpoints of our arc. Okay, a minor arc is less than 180. A major arc is more than 180. One thing to keep in mind is that if we have a minor arc, you only use 2 letters. If you have a major arc, you have to use 3 letters to make sure that you're referencing that you have to go over 380 degrees. Okay. An intercepted arc is the arc that, let's see here, I'll just read it. A part of the circumference that lies inside of an angle whose endpoints are where the angle crosses the circumference. So where the angle crosses the circumference. So this red arc right here is the intercepted arc. It's where that angle intercepts the circumference, okay? So we're looking for arc AB here in red is our intercepted arc. Okay, a semicircle is half of the circle. It's the blue, not the red. The red is the diameter. You have to have endpoints of this arc that are the diameter in order for you to make sure that you have a semicircle, okay? And then we've got some formulas here. So I just had you write these formulas down for reference. The area of a circle is pi times your radius squared. Your circumference is 2 times pi times your radius, or your circumference could equal your diameter times pi. And then what we did is we said arc length is S equals, and I just used S because we'll have S stand for arc length. Put arc length here. Okay. We take this first part is our circumference, so 2 pi r, you'll notice that it's the same right there, 2 pi r, 2 pi r. We take our circumference, and then we multiply it by whatever portion of 360 that we want. That's why we have theta as our central angle divided by 360. So if circumference was all the way around a circle, if I wanted to find part of an arc length, I would have to take this central angle theta here, whatever angle this was, and I would have to multiply my circumference by that and then divide by 360. So that's the idea of this formula right here. The circumference times this ratio, theta divided by 360. Okay, so quick video, rewatch it, fill out the notes, turn them in, so we can use these to practice on Wednesday or Thursday in class. Hopefully it helped.